All right, welcome to the after work video. We're gonna continue more on BGP communities. Unfortunately, I do feel like I'm pretty well learned in this topic, so I kind of feel like I'm being a dead horse at this point, but hopefully we've just got this one and one more and we can move on quick. But this is extended communities in a routing policy. An extended community is similar in most ways to a regular community. Some networking implementations, such as virtual private networks, VPNs, use extended communities because the 4-octet regular community value does not provide enough expansion and flexibility. An extended community is an 8-octet value divided into 2 main sections. In this example, device R1 and device R2 are OSPF neighbors in autonomous system 64510. Device R3 has an external BGP, eBGP connection to device R1. Device R2 has customer networks in the 172.16/16 address space, simulated with addresses on its loopback interface, LO0. Device R1 has static routes to several 172.16.x/24 networks and attaches regular community values to these routes. Device R1 then uses an export policy to advertise the routes to device R3. Device R3 receives these routes and uses an import policy to add extended community attributes to the routes. All right, so let's do a step-by-step configuration. I think everything, let's see what so device R1 here is gonna have a connection on 0 and 3. What do we got? So we've got a connection on 0. We've got one on 3. Let's see here, device R1. Nope, we got one on 2. So we've got on 0 and 2. So let's wire it up as if it were in the topology. That's one thing I didn't do in the last video when I reset up this topology. I kept the wiring as it was. So we're gonna do port 0 here, port 0 here, and port 1 here, and port 1 here. Perfect. Now let's start by configuring device R1. So this looks like a very similar setup to the previous lab, but it's always good practice to reconfigure things, and then the faster you are on the command line, the more time you have to pass the test. One thing I might want to do is not rely so much on the documentation, since I won't have it during the, well, I will have documentation, but it of course won't be telling me specifically what I need to do. But I consider myself to still, on some level, be in the early stages of studying for this exam. So I wouldn't want to really challenge myself at these stages. I would want to do things that I'm more able to succeed in now, and then the real challenging things are going to come a little bit later. The most challenging of which will probably be the exam. Well, hopefully, actually, I think if I prepare well enough, the exam actually won't be the most challenging thing. All right. So these actually are going to have a next hop. Oh, and it looks like they're all going to have the same next hop. All right, time for device 2. R2. So here's the simulated addresses that will be serving as customer routes, except for that one. That's the router ID. Be used for management and control traffic source addresses. Once I do the verification steps, I think I might actually take advantage of that those management addresses. Well, I mean, it is kind of a big thing to enter in those keys. So as I said in other videos, there's a lot of topics on the exam. So I think I might leave the management server out of it for now, just to kind of move on. But let me know in the comments if that's something you want to see more of, is the management server, because I think that was pretty useful. But anything that goes too far off the rails of what's going to be on the exam, of course, I'm not going to want to focus on too heavily. Oops, and it looks like this says that it goes to port 3, but in the, oh, it does say 3. Well, it's not too hard to just sub out what I've got. I've got port 1, show in terse, pipe match, G dash. I'm going to use port 1 instead of port 3. I wish. All right. So here we're going to have a policy that adds community strings onto these routes, and then we're going to be exporting them. Wait, what? Are we not going to be exporting them? We're going to be importing them. Okay. Why are we not going to be exporting them? Okay. Well, let's just do the exercise and hopefully it'll make sense later. But hopefully my confusion is understandable because, oops. Oh, router filter, route filter. Because if you're adding a community string to a route, there's really no reason to do that unless you're exporting it, because you can't make decisions like just when the route goes from your from the routing protocol to the routing table. I don't think there's at that point any advantage of having a community added to the route then and have it show up in your routing table, unless you want to make your routing table kind of look nicer to have those on. That's probably maybe what they're going at. Is just when you look at your routing table, they have all these attributes on them, and you can tell at a glance what some more information about the route. So, okay, that makes sense. That's kind of that's a way I can kind of rationalize or better understand why you would need to add communities, which are, we can remember that they're optional transitive. So the fact that they're transitive, they're passed on from router to router. So I was kind of thinking that a optional transitive would be intended for passing between router to router. But as we can see here, there could be many other kind of strategies. One of them being, instead of intending them to be passed on, just marking up your BGP table with more useful information, even though it might not necessarily be used to set up some sort of policy or whatever, because by this time it's too late. That's why I was confused that they would be doing it as an import, because you would be more, I would have expected them to be matching instead of adding at this point. It's kind of, there's no point in adding it aside from that little bit of extra help to whoever's reading your routing table. But I mean, that itself can be really valuable, especially for automation efforts. So I can think of many reasons why you would want to use an import statement that adds community routes and not just an export, or adds community strings and not just an export. So route filter 172.16.2.0. Oops, I forgot the except statement. Oops, and it looks like I wasn't, let me see what I got here so far. So I've got term route 1, and I've got term route 2, but then I've got these extra things that aren't a part of a specific term. So I'm gonna have to start over again with these. And then I'm going to need to apply them to term 2, term route 2. If enter key will work, there we go. So this is not going to be that difficult. Perfect. All right, so now things look a little bit better. There we go. So now it's time for term 3. One thing I'm kind of surprised about, though, is that there's more than 3 for term 2. It should be 1, 2, 3, 1, 2, 3. So it should be 3 statements per term: a route filter, a community add, and an accept. So for term 1, we've got the route filter, we've got the community add, and we've got the accept. Aha, but here we go for term 2. It looks like we've got an extra route filter, so I'm going to delete that. Oops, if it will let me do that. Looks like it's not letting me do that. And I've got an extra community add. So target IP is the only one that needs to be added for term 2, so I will delete origin AS. All right, and now it looks like term 3 is going to have that information. Perfect. Oops. Oh, right, it's set from route filter. Set then community add origin AS. Set then accept up edit term route dash 4. Set from route filter. Exact. Set then add origin IP. Perfect. All right, so one last section of policy options remains, and that's for the community. And it looks like we're going to have 4 different communities. First one, going to be origin-AS. Kind of some interesting terminology here going on with origin and targets. It's nothing we read about above. I kind of wish they would have explained that a little bit more instead of just using it in the config right away. Aha, but here we can see there are multiple formats here. So there's the autonomous system, and there's also an IP address being used. So let's kind of slow down and look at some of the help information, and maybe it'll give us a clue as to the syntax that is required. Nope. So unfortunately, we don't get a special clue into what the syntax is. Sometimes you can get that, but not all the time. All right, so we've got all 4 of our policies looking really good, except for this one doesn't look so good. It's missing the targets, so I will add that. Kind of a tricky bit of typing there. I'm kind of glad I'm doing this exercise because these are definitely pretty sophisticated commands that are going to be quite difficult to troubleshoot during the exam. So as much extra practice as I can get on this, I think is going to be valuable. I was worried that I was investing too much time on this, but as is clear from the difficulty I am having entering it in effortlessly, it is very effortful for me to enter this in. Any extra practice is going to be really valuable. Configure the policy that adds extended community values to the routes received in device R1. An extended community uses a notation type administrator assigned number. The specific community values can be anything that accomplishes your administrative goals within certain parameters as explained in community. Okay, so here's the verification commands, and I'll make sure to have Wireshark be a part of this video. I'm kind of sorry I missed it in the last one, but I'll definitely be snipping both of those links. But let's start with the first verification command and get a Wireshark capture going and just running in the background, and then we'll go and look at that in more depth afterwards. So we're going to start on router R1. All right, and we can see we've got all 4 of the routes, and all 4 of them have the community on it. So that looks really good. So the output shows that the regular community values are attached to the routes. The communities are attached to static routes, you can see here, thus demonstrating that communities can be attached to non-BGP routes. Okay, and that's a really interesting thing to know. And we actually had seen that before because we learned about redistributing it into ISIS. So communities aren't all about BGP. They're just about, it's just an extra thing you can assign to any route at all. And then you can match against that thing and take any action, take actions based against that matching. That's all it is in a nutshell. And of course, it can get as complicated as they possibly make it on the exam. I bet you this will be a pretty large section with a lot of really complicated, difficult things to dive into. So it's going to be important I get as much practice as I can in this, and that I can kind of handle anything that comes my way. But I think I can, as long as I am comfortable using those commands. Show route detail. This is going to be really important. Show route hidden. That's going to be important. Show route receiving protocol BGP. Show route advertising protocol BGP. Those are all going to be really essential commands. Even show route advertising protocol Oh, so it's only valid, it's not valid with like OSPF and stuff, but there are different kinds of commands that can be valid for that. So just kind of having a good understanding of how routing information is exchanged is going to be essential. Okay, so there is an issue here. I'm not sure what happened. Let's look at the running config. I'm surprised that the configuration wasn't applied. So it looks like it says to router 1. Yeah, that seems right. Not sure why. Is it a hidden route? Nope. Aha, so we're in connect state. So the BGP session is not created. It is not up. So it's going to be to 14. So of course, a really good first step. Can you ping it? Now, okay, I can't ping it. So now a good second step, show route protocol direct. So sure enough, I've got this directly connected on this interface. So I've got 13 directly connected, and I'm trying to ping out to 14. Let's take a look across the wire and try to understand why I can't ping that. So let's take a look at GE001. Oops, and G001 isn't even configured, so obviously we're going to have a lot of difficulty forming a BGP neighborship. Yeah, it just never got configured at all for some reason. Oh, so it looks like I put 2 addresses on 000. So really good troubleshooting, kind of stuff that'll be on the exam for sure. Just kind of careless mistypes. Those are going to be, I think, a big part of the troubleshooting section. Or at least they'll be the easy ones, and I'm definitely going to want to get the easy ones right. There we go. So hopefully that neighborship will now come up. We'll see if we can get a open confirm. Those are always exciting because those are the quickest. That's the state that BGP transitions through the quickest. So it's the most rare to see on the command line. So let's see if we can ping 13. It looks like we do have an external neighbor to 13. Yep, so we can ping 13. Aha, so it just took a while. And another reason why it might have taken so long is because we didn't use that passive keyword. So we had that race condition. So it had to compete for who starts that session. And then it had to back off and restart based on, back off and succeed based on who had the highest IP address. So let's take a look at that one more time. It's been a while since we've seen that race condition. And I'll just, it's okay if there's a messy capture. It'll be good to, I'm not trying to look at anything in specific, just kind of in general, the traffic patterns. So kind of see all the dirtiness is going to, I think, be useful. Okay, so we do have some TCP SYNs. Here we go. So yeah, lots of good stuff happening. It looks like it was able to establish one. We see we did have some TCP SYN messages going because it was set up on R1. It's like we got a FINAC was being sent out, but here's this first SYN, didn't quite work because ARP wasn't up. So now here's a three-way handshake: SYN, SYNAC, ACK. So I think there was an erasure condition this time because 14 wasn't even able to participate in the erase because it was not receiving anything from 13. 13 was the clear winner. But let's try to see that race condition again because it's been a while since we've seen it. So R1, configure private, rollback 1, commit. And now rollback 1 again and commit. And let's wait until we get the the FINAX. It looks like it might have stopped capturing though. So I'm going to restart it. Okay, so we've still got those keep alives. So that's interesting because we won't be able to ping right now. So I kind of wonder if, yeah, it looks like the keep alive is being sent from 13. So I doubt we'll see one set from 14 because that's now got that error in there that I had originally typed in where I configured 2 IPs on one address instead of an IP on each interface. But let's see if, here's a notification message. So perfect. Hold timer expired. So it's going to keep trying to send those keep alives, but each time it does that, it's going to decrement its hold timer because it's not receiving responses back. And then eventually it'll say, okay, I don't know what's up with you, but you know, if you get this message, this is the last message you'll hear, click. And that's the notification message. Shows up on their answering machine with a major error code, and then they stop receiving BGP messages, and then 13 will just go back to sending SYN floods to try to reestablish a connection instead of keeping one alive because it realizes there no longer is one because it didn't respond back to those keep alives before the whole time expired. So let's make it so 14 now starts sending out those SYNs as well. Oh, and it looks like unfortunately the capture stopped. Okay, so I'm going to start a fresh capture, and I might have to wait for the hold timer to expire again. What I can do is on 13, which is going to be, I believe, router, let's see here, terse pipe match G dash. Yeah, so router has 13. So I can do a show BGP neighbor on there, show BGP summary. So yeah, even though I can no longer ping 14, it's still established because that hold down timer hasn't expired yet. But we should be able to see how much time is left on the clock through an additional command. So here we go. Our hold time is set to 90 seconds, so that's quite a bit of time. Error, hold time, timer expired error. So, oh, let's see here. Last error. This is the last error it was in. So it's wanted to go back into that error state. Ah, looks like it's in there now. Yeah. So, yep. So if I go back into show summary, now that that whole timer has expired, it's back into connect. So hopefully that Wireshark Capture will come back. I don't know what happened to it. There we go. And now I can hit commit and we'll see that race condition again. It's been a while since we've seen that. So here we got a SYN from 13. Oh, this is interesting. We actually got a keep alive from 13 as well. That's interesting because I thought the hold timer had already expired and it had already left established states. There's more to the story, it appears. So now we can see 13 sent out a SYN here. Got back a SYN-ACK from 14. I got that SYN there. But here's our good old-fashioned race condition. So 13 did it. It was successful. Perfect. SYN, SYN-ACK, ACK. We're established. But 14 didn't know that 13 was doing that too. SYN, SYN-ACK, ACK. 14's established now too. So 13 sent out a BGP open message. So BGP is now open on, but being initiated by 13. 14 sent out an open message as well saying, I initiated the BGP session. So now 13 is going to be, oh, I see that you have initiated this section, and I see that you're a higher address than me. I'm only 13, you're 14 in your last octet, and the rest of our octets match. So here's your notification. Here's an error message, or sorry, here's another open message with a notification message saying connection collision resolution, meaning I will back off. It's all yours. You're the higher IP. You got it. So 13, 14 is going to be like, oh yeah, okay, I got your message. Back off. So here's the FIN-ACK. Just respond to that. You back off. I got it from here. So it sends the FIN-ACK, then the 13 responds with the FIN-ACK, and then there. I think that's all there is to the story. It looks like there's another notification message. One thing we can do is because we know that this is the first SYN, and this is the SYN-ACK, and this is the ACK. So this is the connection that was not ultimately the one that was kept. We can follow the TCP stream on this one and filter it all out. And then we can see very clearly, if this can get out of the way, there we go, that this one, oh, that's interesting. So this one is actually the one that was successful, the one that sourced from 13. I thought it was the higher IP that won, but I might be getting confused because local preference is higher. This actually might be the lower. I'll look that up again. It looks like SYN, SYN-ACK, ACK. So let's see the next one. Yeah, so this is probably the one that lost. So let's follow this TCP stream here. And yep, so this is the one that lost. So it looks like the higher, and this is why it's a good idea to kind of not assume that you've got it and move on and constantly go back and remind yourself. So let's see, BGP race condition. Here we go. So well, maybe that's not the right word for it. Collision. Yeah, BGP collision. Aha, here we go. So collision detection, connection collision resolution. So here we go, straight from the RFC. If a pair of BGP speakers try to establish a BGP connection with each other simultaneously, then two parallel connections will be formed, which is exactly what we see in the Wireshark. Right now I've got them filtered out, but you can see we've got one connection here, starting from 13, SYN, SYN-ACK, ACK, and then BGP open message. And then we've got a second connection here starting on 14, SYN, SYN-ACK, ACK with an open message. So we've got two parallel connections going on. Then two parallel connections will be formed. If the source IP address used by one of these connections is the same as the destination IP address used by the other, and the destination IP address used by the first connection is the same as the source IP address used by the other, connection collision has occurred. In the event of connection collision, one of the connections must be closed. Based on the value of the BGP identifier, a convention is established for detecting which BGP connection is to be preserved when a collision occurs. The convention is to compare the BGP identifiers of the peers involved in the collision and to retain only the connection initiated by the BGP speaker with the higher valued BGP identifier. So this is my source of confusion. Like, yeah, I was right. It's going to be the higher value that wins. But here we can see 13 won, 14 lost. Well, that's strange. Why did that happen? Well, let's go on each of these and take a look. So show configuration routing options, pipe display set relative. And let's do the same thing here. So you see something should pop up right away. It's called the router ID. Well, let's see which one of these is. So show BGP summary. So this is .13 here. It's got a peer to .14. So we would have thought, oh, .14 is going to win, right? Because show BGP neighbor, oh, sorry, show BGP summary. because that 14 is the higher IP going to 13. But that's not the identifier used by BGP. So what it's going to use, configuration pipe display set pipe match, is the router ID to make that determination. So this device, which is configured at 14, that we would think win based on the neighbor address, is actually going to lose because the router ID is 192.168.0.1, but this side has the bigger router ID, 192.168.0.3, and it's based off the router ID, not the neighbor addresses. So what you see in the packet here for source and destination address are going to be used to determine if there is a race condition, because if and a race condition isn't the right word for it, I think. Yeah. If there is a connection collision, that's what it's called, not a race condition, a connection collision. So if there is a connection collision, that can be determined because the second time it tries to connect, it sees that, oh, well, I have already accepted a connection from 13. I sent out a SYN-ACK. It sent me an open message. I already have a connection to 13. I'm sending out, I already have a connection that's sourced from 13. But wait a minute, now I'm sending out a SYN to 13. I received a SYN-ACK and I sent an ACK to 13. So TCP is not set up to know about that. It requires extra things to be able to tell that. TCP will just be like, oh, well, you know, this is what you told me to do. Just form three-way handshakes. Here you go. But BGP looks at that and says, wait a minute, something's not right here. I already have a connection that's sourced from 13 to my address of 14 in the packet, the source and the destination in the packet. So why am I building packets that source from my address 14 and are sent out to 13? That makes no sense. I could just use the one that's already there. So then you'll get the notification message that says connection collision resolution, and it will share their BGP identifiers. That's always given in the open messages. And then from there, it's decided which one wins based on whichever BGP identifier is higher. So another review of that. It's been a while since we've seen that, and that's definitely a more advanced concept, and one that requires a lot of, I think, repetition to truly be comfortable with. And when I first introduced it too, I kept calling it a race condition. And I really don't think it is something that could be accurately described as a race condition. It's more accurate to call it a collision detection mechanism, or a connection collision. That is what it is. It's a BGP connection collision, not a race condition. I mean, you can think of it like that way, like, oh, they're racing to connect to each other, but these conditions are kind of their own thing, and connection collision is a better term to use. Okay, but that was it for this exercise, it looks like. Yeah, I just wanted to show that the routes are in there. And then router 3, I did it, and it looks like they're all in there too. So all of the routes are there. All of the communities are there as well. I'll just match out for it so we can see them. Yep, so everything looks great. So thanks for watching. We went back over the thing that I had described previously as a BGP race condition, and we saw it again, kind of learned more about it and got a deeper understanding of it, realized that race condition really isn't the best term for it. The best term is going to be connection collision. And we saw that happen. We saw how the connection collision gets resolved, and that's by using the BGP identifier, not the neighbor addresses, not the information in the connection, such as the source and the IP address. The BGP identifier, it uses that to resolve the collision by choosing the router with the highest identifier as the router that sources the connection, even if the source address would then be a lower source address in the packet. So hopefully that's clear. If it's not, let me know in the comments. But until then, thanks for watching, and I'll see you in the next video.